Welcome to the Deep Dive. Today, we're diving into the life of Robert Hooke, a 17th century scientist who really kind of shaped the world. You probably know him from his law of elasticity springs, but there's a lot more to this guy.
Yeah, Hooke was one of those people whose curiosity just spanned every field imaginable. A true Renaissance man, but unlike some other famous people at the time, like Isaac Newton, his name isn't as well known.
Right. And that's what we're here to change. We've got some excerpts from his biography and some things from Wikipedia already to show how this forgotten genius changed the world. So where do we even start with a guy who did so much?
I think a great place to start is his work in microscopy. His book, Micrographia, published in 1665, was a revelation. Imagine a world before photography, before widespread printing of images. Hooke's detailed illustrations of the microscopic world were like opening a window into a universe no one had ever seen before.
And it wasn't just about pretty pictures, right? These illustrations actually advanced the way science was communicated.
Absolutely. These drawings allowed people to actually see the unseen world for the first time, from insects to the patterns on a fly's wing. It really sparked a wave of curiosity and investigation, and you can see a direct line from those early illustrations to the incredible scientific imaging we have today.
It's mind-blowing to think about how one person with a microscope could change how we understand the world. Speaking of which, we can't talk about Hooke and microscopy without mentioning the word he coined after looking at a thin slice of cork.
Ah, yes. The cell. Think about the impact of that single word. Before Hooke, no one knew that living organisms were made up of these tiny, self-contained units. It's like discovering the building blocks of life itself.
And it's amazing how such a simple observation could be so important for biology, medicine, and our understanding of how life works. What do you think was going through his mind when he saw those tiny compartments in the cork?
I think it speaks to his ability to see patterns and connections others might miss. And his observations weren't limited to plants. He also looked at microorganisms, describing the microfungus mucor in detail. Remember, this was long before powerful microscopes and ways to grow microbes, so his observations were truly groundbreaking.
So he was basically laying the groundwork for the whole field of microbiology years before people like Leeuwenhoek became famous for their microscope work. It's like he provided the first look into this hidden world teeming with microscopic life, and it completely changed the way we think about life on Earth.
Exactly. And his influence didn't stop there. Hooke's curiosity wasn't just about the microscopic world. He was also fascinated by space and the things in it.
Right, so how did this microscope guy end up in astronomy?
Well, Hooke believed in the power of observation and better instruments to make those observations. He designed and built a 12-foot-long telescope, a real feat of engineering for the time, and used it to make some remarkable discoveries. One of the most striking examples is his observation of Jupiter's Great Red Spot.
Wait, wasn't that Cassini who first observed the Great Red Spot?
Cassini calculated the spot's rotation period, but Hooke actually documented seeing this massive storm system earlier. He was a meticulous observer, and his notes and drawings give us valuable insights into the early history of astronomical observation.
So he was ahead of some of the biggest names in astronomy. And it wasn't just about observing what was already known. He was always pushing boundaries, even trying to measure the distance to a star, Gamma Draconis, using parallax.
That's a perfect example of his ambition and ingenuity. Even though his equipment wasn't good enough to get accurate measurements, the idea of trying to measure stellar distances in that era was audacious. He was trying to answer fundamental questions that had stumped astronomers for centuries.
And even if he didn't always get the answers, his willingness to try to experiment, to think outside the box, had a lasting impact.
Absolutely. His attempts to measure stellar distances helped later scientists who refined those techniques and eventually made those measurements possible. Think about the advancements in astrometry we have today, all stemming from the work of early astronomers like Hooke.
It's incredible how these early explorations of the universe helped us to understand the cosmos as we do today. And speaking of pushing boundaries, we can't forget about Hooke's work on gravity and his, shall we say, interesting relationship with Isaac Newton. This is where things get a bit, well, dramatic.
It's certainly a complex and often debated part of the history of science. Hooke, through his writing, showed a clear understanding of the concept of gravity, this idea of a force that attracts objects to one another.
So was Hooke describing gravity before Newton? How did he understand how these forces worked?
Well, he proposed that all celestial bodies have an attractive power. He also said that all bodies move in a straight line unless deflected by some force. And he even proposed that this force of attraction increases as objects get closer, hinting at what we now know as the inverse square law. However, While he grasped the concept, he hadn't mathematically proven it in the rigorous way that Newton later did in his Principia.
So it's like he had all these brilliant ideas but hadn't quite nailed down the math to solidify them.
Exactly. And this, of course, led to some friction, especially with Newton. There's that famous letter exchange from 1679 where Hooke essentially claimed credit for the inverse square law, which didn't sit well with Newton.
It's a classic tale of scientific rivalry and the complexities of assigning credit for groundbreaking discoveries. But even with all the drama, it's important to recognize that Hooke's insights into gravity were revolutionary for their time.
Absolutely. His work on gravitation, despite not being fully formalized mathematically, helped change how we understand the universe. It's a reminder that science often progresses through the contributions of many individuals, building upon each other's ideas, and sometimes even engaging in heated debates along the way.
It's fascinating to see how those scientific rivalries and collaborations really push our understanding of the world forward. But, Hooke's impact wasn't just about the really small and the really big. He also did a lot for something much closer to home, the city of London itself.
Right. After the Great Fire of 1666, Hooke played a crucial role in rebuilding London, using his scientific mind for the challenges of architecture and urban planning.
So we're talking about a guy who could go from the mysteries of the cosmos to figuring out how to rebuild a city after a fire. That's quite a range.
It really shows his versatility and his desire to use his knowledge to solve real problems. As surveyor to the City of London, Hooke worked alongside the famous architect Christopher Wren and contributed his scientific and engineering expertise to the rebuilding effort.
And it wasn't just about bricks and mortar. Hooke had his own unique perspective, even designing the monument to the Great Fire, which, get this, also worked as a giant telescope. Talk about a multi-purpose landmark.
It's a brilliant example of Hooke's ingenuity and how he blended his scientific interests with his practical work. The monument stands as a testament to the tragedy of the fire and the city's resilience, and it also shows Hooke's multifaceted genius.
Thinking about it, you can see how Hooke's scientific mind must have been so valuable in the rebuilding effort. He would have understood the properties of materials, the importance of structural integrity, all those things that are essential when you're rebuilding a city.
Absolutely. He also helped design important buildings like Montague House and Bethlehem Royal Hospital. You might know it as Bedlam. His understanding of mechanics and materials would have been crucial in making sure these structures were stable and long-lasting.
And then there's the story about St. Paul's Cathedral, right?
Ah, yes. The Dome of St. Paul's. Hooke helped figure out its ideal shape, suggesting that the catenary curve, the natural curve of a hanging chain, would be the most stable and beautiful form. It's a great example of how he connected the natural world with human-made structures.
It's amazing how Hooke was able to use these abstract scientific concepts for practical challenges shaping London in the process. I mean, who would have thought that the shape of a hanging chain would be the key to designing a cathedral dome?
It shows his ability to see patterns and principles in the world and then use those insights to find real solutions. And his contributions to London's reconstruction weren't just about buildings. He also helped plan the city's infrastructure, suggesting wider streets and better sanitation.
So he was thinking about the health and well-being of the people, not just how the city looked. That's pretty ahead of his time for the 17th century.
It is. And it all goes back to this idea that Hooke wasn't just a scientist in his laboratory. He was a citizen, an architect, an innovator who was really involved in shaping the world around him.
It's clear that Hooke did so much more than just traditional science. He really made a difference in the world, from tiny cells to a rebuilt city. It makes you wonder what made him explore so many different areas of knowledge.
I think it was his never-ending curiosity and his belief in the power of observation and experimentation. He didn't just accept things as they were. He wanted to understand how they worked, why they worked, and how to use that knowledge to make the world better.
And speaking of making the world better, we can't forget about Hooke's contributions to other fields like mechanics and timekeeping. Remember his famous law of elasticity?
Of course. Hooke's law is fundamental to understanding how materials behave under stress and strain. It explains why springs work, and it's used in everything from engineering and construction to materials science.
It's amazing to think about how this simple law from centuries ago is still so important for modern technology and design. I mean, we take springs for granted, but they're everywhere in our cars, our phones, even our mattresses.
Exactly. And Hooke's contributions to timekeeping are just as important. He was obsessed with making clocks and watches more accurate, even working on designs for marine chronometers, those super precise clocks that were essential for navigation and exploration.
So basically, he was helping to make global exploration and trade possible, all thanks to accurate timekeeping.
It's a great example of how small advancements in one field can have big effects in other areas, leading to major changes in history and technology.
As we look more closely at Hooke's life, it's clear that his legacy is much bigger than any single discovery or invention. It's about his mindset, his curiosity, his ingenuity, his willingness to take on challenges in so many different areas. It's like he represents the spirit of the Renaissance, this desire for knowledge and the belief that we can solve any problem.
I completely agree. He was a true polymath, a visionary who saw connections where others saw only separate fields of study. And, even though his name might not be as famous as some others, his influence is everywhere in modern science and technology.
It's almost as if his work is hidden in plain sight, quietly shaping our world. It makes you wonder what Hooke would be working on if he were alive today.
That's a great question. With his curiosity and ability to connect different fields, I think he'd be drawn to areas like biophysics, nanotechnology, or even astrobiology.
He'd probably be leading some cutting-edge research team, pushing the boundaries of knowledge, and maybe even causing a little controversy along the way.
I can definitely picture him designing and building new instruments and devices just like he did back then. He loved to make and tinker with things, always trying to push the limits of what was possible.
And remember those amazing illustrations in micrographia? I bet Hooke would be creating incredible visualizations and 3D models to help people understand complex scientific ideas.
He'd be a natural on social media, sharing his insights and discoveries with everyone. Who knows, maybe he'd even have his own YouTube channel explaining the mysteries of the universe with his passion and excitement. It's amazing how his legacy continues to inspire us so many years later.
It reminds us that science is always changing and growing, with each generation building on the work of those who came before. And with Robert Hooke, we're still discovering the full impact of his amazing contributions to knowledge. So what does this all mean for us, the regular people just living in the 21st century? Why should we care about some 17th century guy who most people have never even heard of?
I think Hooke's life shows us that curiosity, being clever and challenging how we think, are important no matter what time period you're in. These are the things that lead to new ideas and progress, whether it's science, technology, art, or anything else. He showed us that you can be interested in many things and still make a difference.
He also showed that even small, seemingly unimportant advancements can lead to huge breakthroughs and change the course of history.
Absolutely. And we can't forget about observation and experimentation. Hooke was amazing at both, and his discoveries from the smallest cells to space came from his careful observations and his willingness to test his ideas. It's like the world is full of mysteries, and we just need to look closely and ask the right questions.
I think Hooke's story also shows how important it is to work together and share knowledge. He worked with architects, engineers, astronomers, all kinds of people sharing ideas and pushing each other to think differently. It reminds us that we can do great things when we work together and use everyone's different skills and knowledge.
I totally agree. And even though Hooke was so brilliant, he also reminds us that science is done by people, and people have rivalries, disagreements, and even drama. But it's often through those messy human interactions that we make the biggest discoveries and change how we understand the world.
So if Hooke were here today, what do you think he would say to all the young scientists, inventors, and curious people out there? What advice would he give?
I think he would tell them to always be curious, to never stop asking questions, and to never be afraid to challenge what everyone else thinks. He'd probably tell them to get their hands dirty, to experiment, to build things, and to really look closely at the world around them. And maybe most importantly, he would remind them that learning and discovering is a journey, not a destination, and that the best discoveries are often the ones we don't expect.
That's a great way to put it. Well, folks, that's the end of our deep dive into the life and work of Robert Hooke. We've learned about his amazing discoveries in microscopy, his work in astronomy, his part in rebuilding London, and even his sometimes difficult relationship with Isaac Newton. It's been a fascinating journey through the world of a true Renaissance man, someone who changed science, technology, and how we understand the world.
It's been a pleasure talking about the many sides of Hooke's genius. And remember, even though his name might not be as well known as some others, his legacy is all around us. The next time you use a microscope, see the dome of a cathedral, or even just lie on a springy mattress, take a moment to think about the quiet but important influence of Robert Hooke.
Well said. And if you're feeling inspired to do some exploring yourself, here are a few ideas. First, look up some images from micrographia. Those illustrations are truly incredible even today. You'll get a glimpse into the tiny world that fascinated Hooke and led to his amazing discoveries.
And if you're ever in London, make sure to visit the Monument to the Great Fire. It's not every day you get to stand inside a giant scientific instrument designed by one of history's forgotten geniuses. It's a great way to see Hooke's cleverness and how he shaped the city he helped rebuild.
And if you want to learn more about the science itself, check out the history of the inverse square law. It's a great story of scientific discovery rivalry and how ideas change over time. It gives you a look into the minds of some of the greatest scientists ever, including Hooke.
But most importantly, keep that spirit of curiosity alive. Look at the world, ask questions, learn new things, and never stop exploring. You never know, you might make your own incredible discoveries along the way.
I love it. Keep exploring. Thanks for joining us on this deep dive into the world of Robert Hooke. Until next time, keep those minds curious and keep exploring.